Chapter 5.1. In Chapter 5.1, we're going to be first discussing what are called random variables, and then we're also going to look at probability distributions, and then in 5.2 we'll get into binomial probabilities. So first, let's start talking about what random variables are. Now, before we do, first we look at statistical experiment, which is any experiment by which measurements are obtained. So this is gathering data where you gather measurements. Okay, so the definition for a random variable. First, it's a quantitative variable. So quantitative means it's a numerical value, okay? Such as a random variable, which is also known as an X variable, is the number of eggs in a robin's nest. So when you gather data, you'd go look in bird's nests and you'd say, okay, there are 0 eggs, there are 5 eggs. So you're gathering a quantitative or a numerical value, and it's known as an X value. Another random variable would be measuring daily rainfall, counting the number of defective light bulbs, measuring the weight of a polar bear. So those are all examples of random variables. Now, one of the things that you're going to be asked to do is you will at times be given a list of random variables, and you will be asked what type of random variable that they are. Well, in that type of a question, I am asking, is that random variable known as a discrete random variable or a continuous random variable? So let's look at what those definitions are. Discrete is it can only take on a finite number of values. It's countable. So that would be 0, 1, 2, 3, 4, 5. Whereas continuous can take on a countless number of values in a line interval. So when you think of a number line between two numbers, such as between the number 1 and 2, there are infinite values. You could have 1.1, 1.11, 1.111, 1.12, 1.13, and it's an infinite number, so that's what we call continuous. So you will be given examples such as these 4 bullets where you're given random variables, and you will need to tell me if they are discrete or continuous. So the number of eggs in a robin's nest is a random variable. When you count the number of eggs, is that a discrete value or a continuous? Well, eggs would be discrete because when you look in the robin's nest, you would say there are 4. It's countable. You're counting the number of eggs. All right, the next random variable, daily rainfall. Well, rainfall, what type of a numerical value can it have? Well, it's more than just countable. We have more than just 1 inch or 2 inches. You can have 1.25. You could have 1.3 inches. So rainfall would be considered a continuous random variable. All right, the next, counting the number of defective light bulbs in a case of bulbs, that would be discrete. Because when you look in a case of light bulbs, you would count, oh, there are 1, 2, 3 defective ones, so it's countable. And then the last one, measuring the weight of a polar bear. Well, anytime you take weight, although most scales will say like 122 pounds, 123, if you get a more exact scale, it would say 122.5, 122.3. So weight is continuous because it can fall not just on a number or countable. Then we get into the discussion of a probability distribution. So this is the probability distribution of a discrete, so a countable random variable. So our X value, or our discrete random variable, is the number of appliances sold on a given day. Now that's countable because you don't sell 1.5 appliances or 1.2 appliances. You sell either 1 or 2 or 3. So notice I already have this all filled in, but our X value, this is how many appliances we sell on a given day, anywhere from 0 appliances to 7 appliances. F is the number of days that many appliances were sold. So 9 means 9 days I went into work and I did not sell any appliances. 72 days I went into work and I sold 1 appliance, all the way to 5 great days where I sold 7 appliances. Now, the reason we had to find the summation of this is because when we go to find the probability, we need to do F over N. So what I've done here is I have found the probability of selling that many appliances. So I did how many favorable outcomes. There were 9 days out of 240 that I sold 0 appliances. So I converted that to a decimal. Now, in some of the problems that you do, if the percentage is already given, in some problems in the book, you will not be given F. You will just be given X, and then you will be given the probability in percentage form. Well, if they tell me 4%, I know that's 0.04. So sometimes all you have to do is convert that percentage to a decimal, and you will not have to do the F over N. It just depends on the problem. So for each one of these, I have done the favorable over the total, I've done F over N, and I have converted those into its decimal. And again, I did rounding, normal rounding rules to 2 decimal places unless it was a terminating decimal. And recall that this column right here should add up to 1 or very near 1. Now, I believe this one does add up to 1. You might add it up and get 0.98, 0.99, 1.01, 1.02. That's fine, because with rounding, that's going to happen, but you're not going to get too far off of that other than maybe 0.98 or 1.02. Now, we're going to go to the next page of the notes, and we are going to use this table, so keep it handy. We're going to use this table to answer probabilities. So, on the next page of notes, you will see that a probability is asked. Now notice it has X, that's the number of appliances sold, between 2 and 5. So since this says less than or equal on both of these, that means that what is the probability that we sold 2 appliances or 3 appliances or 4 appliances or 5 appliances? And remember, or is the addition rule. So it's written the probability of X being between or 2 and 5, and this is the probabilities that we're going to add. So I go to my table, and the probability of 2 was 0.26. The probability of 3 is 0.17. The probability of 4 is 0.12. And the probability of 5 is 0.06. So what you're going to do is you're going to add all of those, and it adds up to 0.61. Now remember, when we're asked to find the probability, we leave it in decimal form, and it's a number between 0 and 1, so I know I'm okay on that. Then, if or when you're asked to explain your answer, it is wanting you to give a complete sentence form. So that means a capital letter, period at the end. So you might word it as there is a 61% probability. Now notice when I am explaining and putting it into a sentence, I go ahead and can convert it into a percentage. If you leave it as a decimal, that's fine. There is a 61% probability or chance of selling 2 to 5 appliances in a day. And that would be all I would be asking for. All right, the next one wants to know, what is the probability that you sell at most 2? Well, at most you have to be careful of. At most means that you sold 0 appliances or 1 appliance, or at most 2 appliances. So these are the ones that you would include for at most. So 0 is 0.04. And again, I'm going back to my table from the last page of notes. Probability of 1 appliance is 3, and the probability of 2 appliances is 0.26. And so I'm going to add all of those up, and when you do, you get 0.6. And if you were asked to explain that, then it would be something to the effect of there is a 60% probability of selling at most 2 appliances in a day. And just be sure that you capitalize and end your sentence with a period. And then the last one is that the number of appliances is less than 2 or greater than or equal to 6. So that would include 0 and 1, it would include 6, and it would include 7. So again, I'm going to go to the table and I'm going to find each of those probabilities. So 0 appliances was 0.04, 1 appliance was 0.3, 6 appliances was 0.03, and 7 appliances is 0.02. And we add all of those up and it adds up to 0.39. So that's how you use a probability distribution table. Now, you will also at times be asked to graph a probability distribution. Okay, so it says put the probability on the vertical axis. Let me get this all the way up so you can see everything. Okay, so here's my probability, the probability of X, that's on my vertical axis. Put the random variable on the horizontal axis. So in this particular case, our random variable is 0 appliances sold all the way up to 7 appliances sold. And notice I labeled my horizontal axis. The bars touch, and the height of the bars is the probability of that value of the random variable. And then title and label. So I went ahead and titled it. I've already got that written here, and then I've labeled. So we sold, or the probability of selling 0 appliances was 0.04. So 0 appliances was 0.04, and I always put the number above my bar. Then 1 appliance was 0.3. Now be careful, do not put 0.3 smaller than that. That would be graphing 0.03. Up here is 0.3. 0.3 is 0.30. I've seen students accidentally do that. And then we have 0.26. 0.17. 0.12. 0.06, 0.03, and 0.02. And that's what my graph would look like. Now again, be sure you put the numbers above the bar, you label, and you title. Now, if I ask you what distribution shape this is, and remember our distribution shapes are symmetrical, uniform, skewed left, skewed right, or bimodal, this is obviously skewed right. Then the last page of 5.1 notes, this takes a little bit of calculation. For this particular chapter, it is the most involved on your calculations. So the formulas look bad, but if you understand how they work, it's really not too bad. Now, we're first going to find the mean, and the way that will be worded is the expected value, such as how many appliances would you expect to sell on any given day based upon your probability distribution. So mu, if you remember, that is a population parameter. Mu is the population mean. This reads the summation of x times p of x. So this first question says find the expected number of appliances sold in one day. My keyword is expected, which means to find the mean. So I'm going to use this formula up here, the summation of x times p of x. So what that means is I have to take x times p of x first. So I've done this over here on the side. I'm going to multiply x, so here are all of my x values, times their p of x that is on that probability distribution. So some of these I can do in my head. I'll have to use a cheat sheet on other. 0 times anything is 0. 1 times 0.3 is 0.3. 2 times 0.26 is 0.52. 3 times 0.17 is 0.51. 4 times 0.12 is 0.48. 5 times 0.06 is 0.3. 6 times 0.03 is 0.18, and then 7 times 0.02 is 0.14. So these are all of my x's times the p of x, and so based upon the formula now, I just find their summation. So what you would now do is go to your calculator and you would add all of these values up, and when you do, you get 2.43. So what we have just calculated is mu, population parameter, population mean, is 2.43. Now what that tells me is, based upon my probability distribution, which was that table on the first page of the notes, any day I go into work, I expect to sell 2.43 appliances. Well, we all know you can't sell 0.43 appliances, so basically this number tells me I most likely on most days sell anywhere from 2 to 3 appliances in a given day. That's what I expect. Then you will also be asked to calculate the standard deviation. Now this takes some more calculations. It's the square root of, the summation of. So first, for each x value, we need to take x minus mu, mu is what we just calculated, squared times p of x. So here's what that will look like. And this is the one that has the most calculation on this, and guarantee it that this will be on a test. So what I've done is I've already here's all my x's. So here is my x minus mu, and notice mu is what we just calculated. You square that, and then you take times 0.04. Now, you can put all of this, or each individual one, on your calculator. See if I can get this where you can see it. So what I'm going to do is open parentheses, zero minus 2.43, close parentheses. Then you're going to push the x squared button, times, and then in this particular one it's 0.04, and I know you can't see that very well, but hopefully you can kind of see what I'm doing. There we go, 0.04, and then I'm going to push equals. So we get 0.236196, and I'm going to round that to 0.24. Let me do one more and see if I can get the next one where you can kind of see it on the calculator a little bit better. And then I'm just going to give you the answers to the rest of them. Okay, so I would do open parentheses, 1 minus 2.43, close parentheses. Whoops, my 4 didn't get in there, did it? You're going to square that, times, and then for 1, I'm going to multiply it times 0.3. So I did times already, 0.3 equals, and I get 0.61347, so I'm going to round that to 0.61. And I'm going to go ahead and give you the answers to all the others, but be sure you know how to calculate that on your calculator. So the next one is 0.05, and then we get 0.06, 0.30, 0.40 or 0.4, you don't have to put the 0, I just went ahead and went 2 decimal places out, 0.38, and then the last one is 0.42. Now that's taking x minus mu squared times p of x for each of your random variables. Then you need to do this summation, which means add all of these numbers up, and when you do, you get 2.46. Now here's what you need to be careful. 2.46 is not your standard deviation, sigma, okay? Because the formula says to take the square root of that. So the standard deviation, population parameter sigma, the standard deviation is the square root of 2.46, which calculates to be 1.57. So my mean, I expect to sell 2.43 appliances, but that can deviate the standard deviation by 1.57, give or take. So that is 5.1.